The focus here will be the cell. So we're going to focus on specifically the cell membrane. Remember, the cell membrane is a phospholipid bilayer. It contains integral proteins that act as bridges, and it has a wonderful design that not only protects the cell, but it can choose what it wants to go in or out of the cell, maintaining a homeostasis or a balance of what concentrations are in the cell. Here is a picture of the phospholipid bilayer. Now, the top portion is just one layer, so that's a phospholipid layer. The bottom picture is the bilayer, bi meaning two, think of bicycle, two wheels. So here we have the phospholipid bilayer. Specifically, it's called phospholipid because of the phosphate head and then the lipid fatty acid tail. Remember, lipid, we learned, means fat. So you have a phosphate head. The element phosphorus is in that molecule, and that phosphate head is hydrophilic. It loves water, and the hydrophilic tail hates water, so that's why it's going to be inside. When we look at this picture, you can see the integral proteins. The integral proteins act as gates or bridges, allowing materials through the cell from the outside of the cell into the cell. Now, there are four types of movements or methods of transport across the cell. The first one is diffusion. Diffusion is a passive movement, meaning no energy is required. It can easily move without getting grabbed, picked up, or pushed. Okay, so passive is no violence. Passive is no energy required. So it's going to easily move from a high concentration to a low concentration. A great example of diffusion is if someone has maybe a bottle of perfume or cologne and they drop it. That high concentration of perfume and cologne, the glass shatters, and that high concentration of cologne is in that spot. It starts filling the air and starts spreading. So now it's going to easily move through a process called Brownian movement. The particles are vibrating, and it's going to easily move from this high concentration where all the cologne is to a low concentration throughout the room where it did not smell. And eventually, it will try and create this balance, this homeostasis, in which the whole room is equally filled with the same amount of smell or same amount of cologne particles in the air. So diffusion is moving from high concentration, lots of particles, to a low concentration. Why? To create a balance, to create a homeostasis. Homeo meaning same. Now, number two is osmosis. And osmosis is pretty much the same thing as diffusion. It's a movement of particles from high to low concentration. It's passive, but it's in water. So specifically, osmosis is in water. So that's the key word, water for osmosis. Number three is facilitated diffusion. This is when the cell proteins are going to allow things to pass through. Okay, they're just opening it up, allowing it to pass through, helping in a certain way, but not doing too much. But number four, active transport. This is requiring energy. So basically, imagine if you have a room of like 200 people, it's packed. I mean, there's people kind of on top of other people, we have no room. Well, in diffusion, it would be very easy. We open that door, and let's say we have another room that has only 3 people. Well, we can let some of these 200 fall out of the room and go into the room that only has those couple people. Well, it's easier to let those people into the room that doesn't have a lot of people. But active transport is moving from low concentration to high concentration. So now imagine we're going to flip-flop this. We still have the room of 200 people. We still have the room of just a few people. Well, now we want to take those few people and shove them into the room. It's going to take a lot of effort, a lot of force, a lot of energy to try and get these 3, 4, 5 people in that packed room when you don't even have any door space, right? So with active transport, you're requiring energy to go against the grain, to go against the flow. So that's the key point here is remember, energy, which is an ATP molecule in the cell, energy is going to be used to move the molecules. Here's a picture of diffusion. It's highly concentrated in the blue. It starts spreading in the green, and then it's a lot more spread out in the red. There's another illustration showing the movement of the particles as they kind of vibrate and move. Oh, so the particles are moving from a high concentration to a low concentration in the water. So the water is moving from left to right. Okay, there are three types of solutions. Or no. Okay, the word solution refers to salt or sugar, some sort of solid material, which is called a solute, being dissolved in a solvent. Now, the solvent is what does the dissolving, like water. Water is actually called the universal solvent. So, I'm going to say it again. A solution is made up of both a solute, which is a solid substance that is being dissolved, like salt or sugar, and it's being dissolved in a solvent, which is water. Okay? The material that is doing the dissolving. There are three types of solutions: a hypotonic, hypertonic, and isotonic solution. I'm going to start at the very bottom, the isotonic solution. That's in which we have a balance, a balance of both the solute and the solvent. So the solute is equal balanced. Now, a hypotonic solution is when we have a low concentration of salt or solute or sugar and we have too much water. And so what's going to happen is the cells are going to start to swell because we have too much water, not enough solute. Now, a hypertonic solution is when that same cell may have too much solute, too much salt, so the cell starts to shrivel up. It's kicking out the water, it has too much solute, it's trying to balance the solution, so the cell starts shriveling up. In the same case, some examples would be if I'm drinking salt water or I'm eating too much junk food, or if I'm drinking a lot of like sugary materials, well, my mouth starts to get thirsty, right? So my cells start shriveling. I'm adding too much salt and sugar in my diet, in my bloodstream. So basically my cells are going to shrivel up and I'm going to get thirstier and thirstier. A hypotonic solution is when I'm just drinking water, and then I start feeling kind of dizzy. I'm drinking too much water. That's why they say don't just drink water after sports events, but to drink Gatorade, which has the sugars and the electrolytes and other things, to try and balance out your solutes and solvent. It's still important to drink water, but you don't want to drink too much. Here's a picture of the three types of solutions. You can see the hypertonic solution is shriveled up. It's kicking out the water, has too much solutes in the solution around it. So it's trying to create a balance by trying to get the solution to be equal to itself. So by doing that, it's giving its water, and by doing that, it starts shriveling up. Here's your normal. It's an equal balance of taking in water and getting rid of water, so it's a normal balance. And then a hypotonic solution is there's too much water in the solution, so it starts absorbing the water to create that balance, and eventually it can pop. There's a story in which a woman, I guess she went on a radio talk show and she just drank all this water. Well, she passed away because she drank like 2-3 gallons of water. So we don't ride and row. So we don't want to ever do that or drink too much. We want to have a balance. Okay.